Hello students, today in this video I am going to take a topic from class 12, that is the continuation part of determinant. In the previous video we have seen the properties of determinants and few questions were also solved. But now I am going to take the next part, that is the adjoint of a matrix and inverse of a matrix. So for that, to find the adjoint, I'm going to recall the things that we have already studied in the previous video. That was the minor and cofactors. Now if I go for minors and cofactors of an element, for that, let me recall, if I say Mij, it is the determinant of submatrix obtained by leaving ith row and jth column. Clear? And if I go for Cij, that is cofactor. Cofactor is minus 1 to the power I plus j and Mij. Clear? That is cofactor of ij element is nothing but the minor which will be going to have a plus or a minus sign. यानी minor ही है पर आगे plus और minus का sign आ जाएगा. तो इसको एक बार रिकॉल करने के लिए आई एम टेकिंग अ सिंपल मैट्रिक्स से 0 1 2 -1 2 3 1 and again I take 3 and let us say 4. Now this is one of the matrix given to you. Now when we take this particular matrix, let us find the minor. If I go with M11, it means first row, first column, leave that first row and first column. If you leave the first row and first column, the sub matrix that we will get is 2, 3, 3, 4. Now this is the sub matrix and we have to find its determinant. So determinant means this will become 8 minus 3 into 3, 9, which is minus 1. But if I say the cofactor C11 means minus 1 to the power I plus j. Just keep this thing in mind that we are going to write plus Mij whenever I plus j is even. We are going to write minus of Mij whenever I plus j is odd. So this is the cofactor. Clear? So if I am writing 11 means even, I am going to go plus, but already the sign is minus 1, so the cofactor is minus 1. So this we have already taken in the previous video, clear, where we have discussed about minors and cofactors. Now what I am going to do, I am going to write all the cofactors. so one I have already calculated, so I will be doing it again. But now after recalling this minors and cofactors, I am going to take the main topic, adjoint of a matrix. So as I told you, to take the adjoint we should know what are minors and cofactors, that we have already written. So this I will be keeping it here only. If you want, I will be writing this minors and cofactors here only, and let us find all the cofactors. So I am writing this one as C11, C12, C13. Then I will go with C21, C22, C23. Then I will go with C31, C32 and C33. So for these cofactors, we already know there is a difference of minus and plus with the minor. Minor के साथ plus minus का फर्क है, तो मैं पहले ही plus minus के साइन लगा दे रहा हूँ. This is plus minus plus, this is minus plus minus, this is plus दिस इज माइनस, ये है प्लस का। अब आप लोग यहां पे अगर देखो तो हमें माइनर निकालना है, तो लीविंग द फर्स्ट रो फर्स्ट कॉलम सब मैट्रिक्स बची, तो सब मैट्रिक्स है 2 3 3 4। फॉर नेक्स्ट वन लीविंग द रो एंड द सेकेंड कॉलम -1 3 1 4। नेक्स्ट फॉर दिस वन -1 2 1 and 3। फॉर दिस C21 leaving this row and this column we are getting 1 2 3 4। Then for this one it is 0 2 1 4। For this element it is 0 1 1 3। Next if I go for the last one, so we are having 1 2 2 3। We are having for this element it is 0 2 -1 3, and the last one if I go with that 0 1 -1 and 2। तो ये है हमारे माइनर्स। कोफैक्टर्स निकालने के लिए मैं यहीं पे सॉल्व कर लेता हूं। दिस इज 8 -9 -1। क्लियर, मैं इसके ऊपर एक सर्कल खींच रहा हूं ताकि हम लोग आइडेंटिफाई कर पाए। दिस इज -4 -3 is -7, but already minus sign is there, तो +7। Then we have -3 -2 -5। Then this one is 4 -6 -2, already minus is there, so +2। For this one it is 0 -2। If you say this one it is 0 -1, already minus is there, so +1। This element is 3 -4 -1। This element is 0 +2, already minus is there, -2। And this one is 0 -+1। So we are having our cofactors। अब हम लोग इसको चेक कर लें। इफ आई राइट दिस पर्टिकुलर मैट्रिक्स बाय रिप्लेसिंग द मैट्रिक्स एलिमेंट्स विद देयर कोफैक्टर्स, लुक एट दिस। आई एम रीराइटिंग दिस मैट्रिक्स हियर वेयर फर्स्ट एलिमेंट विल बी रिप्लेस्ड बाय इट्स कोफैक्टर -1 7 -5 2 -2 1 -1 -2 and 1। This is known as cofactor matrix। Cofactor matrix। Now after getting that cofactor matrix, now it is the time to go for adjoint। तो adjoint क्या होता है पहले समझ लें। Adjoint of a matrix is transpose of the cofactor matrix। So now I am rubbing this one and let us write the definition of adjoint of a matrix। Adjoint of a matrix is transpose of cofactor matrix। Yeah, I'll write transpose of its cofactor matrix। That means we are having the cofactor matrix। Now this implies we can write the adjoint of A। In short, this adjoint will be written as ADJ। Adjoint of A will be denoted by the symbol is transpose of this matrix। We are going to take the transpose। Rows will be converted to columns, so this becomes -1 7 -5 2 -2 1। Then we have -1 -2 and 1। So we say this one, the matrix that we are getting is adjoint of a matrix। To verify this one, there is one of the most important property of adjoint। Why we are studying adjoint, वो भी आपको रीजन पता लग जाएगा। The important property is already we have studied in matrix multiplication that matrix multiplication is non-commutative, but during that time period I have told you that this commutative law is okay, it is not valid for matrix multiplication, but एक matrix है जो हम लोग ये commutative law को obey करेगी, वो adjoint ही है। इसका मतलब A के साथ adjoint matrix का multiplication और adjoint matrix into A के साथ A का multiplication will always give you a scalar multiplication with identity matrix। I am writing here n stands for the order। Clear? So here we are getting the adjoint. So I am writing the adjoint here. You can see now the adjoint that we have obtained, I am writing it here. Adjoint of A that we were getting as -1, 7, -5, 2, -2, 1, -1, -2 and 1. So we are getting this adjoint. I am rubbing this part and let us verify. If that is the adjoint, then this property is valid. This is the important property of adjoint of a matrix. So let us check. First I am verifying what will happen with A into adjoint of A. So to get that A into adjoint of A, I am taking matrix A, which is 0, 1, 2, -1, 2, 3 and 1, 3, 4. Multiply by the adjoint -1, 2, -1, 7, -2, -2, -5, 1 and 1. So let us check this one. Matrix multiplication. Take the row and the column. That we know how to multiply the two matrices. पहली वाली मैट्रिक्स की रो और दूसरी जो सेकंड मैट्रिक्स जिसको पोस्ट मैट्रिक्स कहते हैं, प्री मैट्रिक्स you have to take the row and post matrix we are going to take the column, multiply them. So we are getting 0 into the 0, 1 into 7 is 7, then we are having 2 into -5 is minus of 10. Next I'll go with the second one. It is 0 minus of 2 plus of 2. Then I'll go with the third column. It is 0 minus of 2 plus of 2. So this is over. So I have to pick the second row. Now take the second row and multiply in the same way. We are getting 1, we are getting 14, we are getting -15. दूसरा है -2 minus of 4 plus of 3. तीसरा है 1 minus of 4 plus of 3. Next it is over. So I am just writing this one. 1 minus 4 plus 3. Now take the third row. I am taking the third row. We are getting -1 plus 21 minus 20. Next हमारे पास आ रहा है, it is 2 minus of 6 plus of 4. Then we are getting -1 minus of 6 and 4. So you can see this one. The result which I am getting is -3 over here. This is becoming 0. This is also becoming 0. This one is 15 minus 15, 0. This one is -6 and plus -3. Then this is 0. Then this one is also I am getting 0. This one is 0 and -3. We can see this one is a scalar matrix. Scalar matrix, I am going to take this -3 out. We are left with 1, 0, 0, 0, 1, 0 and 0, 0, 1, which is nothing but identity matrix. So I am going to write -3 into I. Instead of writing I, we can write I3 also. So whatever answer we are getting, this is nothing but determinant. So whatever answer I am getting is determinant of A into I3. Hence we have verified the first part. Now if you see the second side also, let us take the second side. There I am finding adjoint of A and its multiplication with A. Clear? If we take this one, so what you will get, let us take the adjoint, which is -1, 2, -1, 7, -2, -2, this is -5, 1 and 1. Multiplying with, we are getting 0, 1, 2, -1, 2, 3, 1, 3 and 4. Now dear students, can you tell me why we are getting 0? In the previous video we have studied when elements of any row multiply by their own cofactors and they are added, that is sum of product of elements of any row with their cofactors will give you determinant. So this was first row, this was the cofactors of first row, done. This was first row and this was cofactors of the second row. That is why we are getting the result 0. The second property, as we have discussed in the lecture, that is sum of product of elements of any row with cofactors of another row will give you 0. So that was the only way. And here if I go with that, we are having the column, but this one is the cofactors of first column. So what you will get, I am just doing it orally, 0 -2 -1, we are getting -3. Next take the other one. It is -1 plus 4 becoming +3 plus 3 and minus 3, it is becoming 0. In the same way, it is minus 2 plus 6, it is 4 minus 4, it is becoming 0. In the same way, you can try this one also, 0, then it will become 0, minus 3 and 0, 0, 0 and minus 3. We are getting the same result. I have done it directly, you can check it also, and we will be going to get minus 3 common. We are left with identity matrix. The left matrix is 1 0 0 0 1 0 0 0 1. So the answer that we are getting is minus 3 into I3 matrix. So this was nothing but determinant of A into I3. So this was one of the important property of adjoint of a matrix, that is, adjoint of a matrix is transpose of its cofactor. And the important property is when A is multiplying by adjoint or adjoint is multiplying by A, first of all they are giving the same result, यानी commutative law obey कर रहे हैं, and the result that we are getting is adjoint of A. When it is multiplied by A, we are getting determinant of A. So there is a trick also, that is, there is a type of question in which they will ask you to find the adjoint and they will ask what is the determinant of the matrix. So you can use this property to do that question. Now once we are getting this adjoint, and we have already verified, the screenshot can be taken. Now the important part, why this adjoint is so much important. Now if I go with the definition of inverse of a matrix, inverse of a matrix, the definition was A is invertible, the square matrix, I'll write here, a square matrix A is invertible if there exists another square matrix B such that A into B or B into A is I. Clear? Then A is said to be invertible. Then what about B? B is inverse of A. This implies we are having the property that A into, what about B? B will be called as inverse, and A inverse into A is equal to I. Now this was the definition. I am using the word was, already पढ़ चुके हैं when we are studying the properties of matrix multiplication and addition. There I have gone with that particular property, that is existence of inverse. Now I will be using this particular definition or the property with this definition. If you can see, there is a simple format, that few things are common. The first thing is A, position of A is common, position of IN is common. So what is left? If I use this one as 1 and this definition as 2, dividing first by determinant of A. And one property I must recall here, if we are having product of two matrices and there is a constant that you are going to multiply, this constant will either be with A or this constant is either, the other part is, it will be with B. That K cannot be there with both of them. If both of them are having K, there should be K a square outside. So if I am dividing with this one, so this will be, this scalar quantity should be either with A or with adjoint. Since I want to have this A here, I'll be writing this one as A into adjoint of A divided by determinant of A, or adjoint of A divided by determinant of A into A is equal to IN. Now this result which we are getting, now we can compare. Let me write this one as, इसे हम लोग थर्ड इक्वेशन बना लेते हैं. Now if we comparing second and third, we can see that A inverse is equal to adjoint of A upon determinant of A. can be written as 1 upon determinant of A into adjoint of A. So this was all about the inverse of a matrix, where one of the important definition I must take here, as inverse is having determinant of A in the denominator, and if denominator becomes 0, we say it does not exist. So that is one of the property, that determinant of A should never be equal to 0. That is one important note. If determinant of A is 0, A inverse does not exist. If that does not exist, so A मैट्रिक्स हमारी सिंगल मैट्रिक्स रहेगी, इसका इन्वर्स नहीं होगा. इसीलिए यहां पे एक और डेफिनेशन आ गई, A is said to be singular matrix. Clear? So along with that inverse of a matrix, we should remember the singular matrix also. So as we have discussed here, we got that inverse, and we are already having one example going on. So I'll be writing this one, removing this definition. We can write now, therefore A inverse is 1 upon determinant of A into adjoint of A, which will give you 1 upon minus 3, and the adjoint is 7 minus 5, 2 minus 2, 1, minus 1, minus 2 and 1. So this was all about today's topic that I have taken, that is adjoint of a matrix and inverse of the same matrix, where we are going to use this particular definition, that is this formula, to find the inverse of a matrix. Thank you.